Hello everyone. In this video, we are going to see special and prosperous string question which came in PrepBytes marathon October 20. Let's see the question. Let's define a special string as a string that can be formed by deleting 0 or more characters from the original string. A prosperous string is a string that can be formed by deleting prefix and a suffix of the original string. The length of the prefix and suffix is greater than or equal to 0. Basically, in this paragraph, the question is saying that we will get a string and there will be, it has given the definition of the special string and prosperous string. And what will be the prosperous, what will be the special string that we can obtain by deleting 0 or more characters from the original string. And what will be the prosperous string? A prosperous string will be the string which can be obtained, which can be formed by deleting prefix and suffix of the original string. So this was the definitions, and you are given two strings S1 and S2. Find all the special strings of each string and find the longest special string that is common. Let's name it S. So we have to find the special string. We will be having two strings S1 and S2, and in between among them we have to find the special string of each string, and we have to find the longest special string, that is the longest thing that are common, longest subsequent that is common in that, in those two strings. Okay, let's name it S, and the string that will be obtained from these two strings after the special string will be named as S. And there is one more condition. You are also given another string S3, and this string should not be prosperous string of S. Okay, so this question is saying us that we will have a string after getting this string S, that is was the special string of S1 and S2. Okay, we will be also having given string S3, and we have to assure this that string S3 should not be the prosperous string of S. Okay, so this is the question, and the constants are small and time limits is 1 second, and this is the input output. Let's better understand this question with the help of example. I have written the important pointers of this question, three important pointers, so that it becomes more clear to you all that two string will be given S1 and S2, and we have to find common subsequence between them, and it should be of max length possible. If it is possible to get max length, then we will choose the max length between the common subsequence, because there can be more than one common subsequence. Okay, now we will have a string S3, and we have to check is this S3 is a substring of common subsequence found from S1 S2. As I told you earlier that we will be also given string S3 like here A, and we have to check that this A is a substring of this. The definition of your prosperous string is this only, because when you will remove the prefix and suffix, you can only remove either the prefix or the suffix. So after removing that, you can only get the substring. Okay, so the prefix and suffix length can be 0 or it can be more than that. So you can only get the substring. So this is the main question. This is the thing which we should understand, that a prosperous string is nothing but it is a substring, that we have to get the substring. And what after getting the substring? If the substring is present, then we will remove it. We will remove that the common, just suppose that this is the string. Okay, and from these two string we got the common special string, that is S. Okay, and now this S3 will be checked in this S. Okay, that this S3 is a substring of this S. If it is, then we will remove this S3. Okay, from this S, and the you can say that we will remove S3 from S, and after removing, the answer will be this. Our answer will be this. Okay, this will be our answer. Now let's understand with this example. Like here it is given S1. S1 is given your triple A BB, and S2 is equal to ABB. Now it is directly visible here that which string is common here. Which string is common here? And ABB, this whole thing is common here. ABB, this whole thing is common here. So among S1 and S2, the special string that can be is ABB. And now, is A is present in this? Is A is the substring? Yes, A is present. So we will remove this, and the answer that will be your BB. It will be your answer. So this was the explanation of the question. This now we have to think the logic and the approach of the question, that how we can solve this question. Okay, how, what formula we can generate, what logic we can develop from this question. Let's think on that. Let's see that. Okay. Okay, so now approach is this, as we can see in this point, that what we have to find, we have to firstly find the common subsequence, and what should be its length, it should be of maximum length possible. So the problem reduces to, this point can be reduces to the problem of LCS, that is your longest common subsequence. Okay, this will be the problem for this point. Now, this, what is this here? What we have to, we will have a string S3 and we have to check, is this S3 is a substring of common subsequence found. So what we are doing, we are matching a string to other string. And what that, this matching algorithm, which matching algorithm is comes to use, which matching algorithm reduces our time complexity and is considered as the best. We can use here KMP matcher algorithm. We can say that this point is there, we can use here KMP method. So this question is nothing, only the modification of these things, and only the, not also modification, you can say, you only the these two concepts will be used, and we will be a kind of, we will be merging these two combine these two algorithms. So the best time complexity, if we use dynamic programming, the prerequisite for this question is longest common subsequence and KMP matcher algorithm, pattern matching algorithm, you should know. And I'm assuming if you're solving this question and then you are knowing this longest common subsequence algorithm and KMP matcher algorithm. Okay, then now how we will make use of this algorithm, how we can make use of this algorithm. Okay, firstly, what we will do, if a string S1, you can say that B, C, D, E, F, G, H, and second string you can say that it is E, F, G, and BC. This is present. Now what we have to find? We have to find the longest subsequence, longest common subsequence. Okay, longest common subsequence. If we apply, if you have solved this longest common subsequence problem before, then you would be knowing that the time complexity, if we are going with recursion, then it will give us TLE. Okay, if we, because recursion cannot handle, and the for the best case we have to use the dynamic programming. And in dynamic programming, the time complexity that will be of your O of n square. Okay, to find the longest common subsequence of among these. And when the longest common subsequence, that is your EFG, and suppose this was your S1, this was your S2, and this I got LCS, and now I have been given S3 is equal to E, F. Okay, now I have to match these two. And what the time complexity is of KMP matcher algorithm? What is the naive approach? Naive approach, the brute force approach of matching two pattern. Okay, firstly I will check for this, then I will check for this. If these two are common, then we will get the, okay, I have found the pattern at index 1. You can say it is index 2, it is index 3. Now I have found the index at 1. If suppose it was not F, it was H, then again we will further check. Again we will further check. If it is cancelled, then we will come back. This will be the naive approach. The naive approach will give us time complexity of nearly of O of n square for this thing. Okay, but if we apply KMP matcher, algorithm here, then the time complexity that will be reduced to O of n. This will be the time complexity. If we use here, I will use LCS. Here I will use KMP. And merging these two, when I will merge these two, then the LCS plus KMP will give us the time complexity of O of n cube. So now, performing this question, we only need these things. To perform this question, we only need these two algorithms. If we know these two algorithms, then we can do this question easily. We have to only do the dynamic program. We have to only perform what we should take. We should take the dynamic programming. We should take not in LCS. We take the dynamic programming array of 2D, two-dimensional. Here we can take the DP array of 3-dimensional. Okay, one for the this for matching string, one of this matching string length, or you can simply take off the length of as the constraint here is of 100. Okay, length is, so you can take till 101. Don't worry, I will also show you the implementation and also explain you the steps, so it will also become clear, because LCS and KMP are used, but the way we are implementing is little bit modification required in the implementation. Okay, because we are merging the KMP measure algorithm along with LCS. So this was the question. Now, what if you don't know LCS plus KMP? What if you are not? We are afraid. Then I will recommend you firstly solve this LCS with the help of DP, then solve this KMP with the help of DP. Okay, with the help of, sorry, it is best algorithm. It will give you O of n. Okay, then after solving these two algorithms on their own, after solving these algorithms separately, then come and solve this question. Then you will better understand this question. If you don't know these algorithms, if you know these algorithms, then simply just apply with the help of dynamic programming, because this question then becomes of dynamic programming. In the dynamic programming, firstly, what we have to do, we have to get the prefix. What we have to get, we have to get the prefix. And for what we have to get prefix of this Prosperous string that is given as a S3. We will get the prefix of this S3, and we will keep a count that what is the prefix, what is it, what is, how can we use it. I will also show you the in implementation. Then dynamic programming array will be used. Then we can also keep a check on the index that we will firstly if I write the pseudo code, we will firstly travel from 0 to that first string length. Then I will traverse from 0 to second string length. Then I will further traverse from 0 to this third string length. And now I will apply here, sorry, now I will apply here dynamic programming. Now here, as the dynamic programming concept will be used, firstly the LCS will be calculated. This is nothing, there is nothing, only the LCS will be calculated, and along with the LCS we will also check the do the matching things. This all will be shown in the implementation. And if you know the LCS algorithm and KMP algorithm, then basically it's a matter of just time. You just need some 2 to 3 you have to just try it from 2 to 3 times, and you will be getting the implementation. Only the main thing is that you should know these two algorithms. These two algorithms, if you know, then you can solve this question. Otherwise, I will recommend you firstly solve this LCS thing, then go for KMP thing, then come and solve this question. Then you will be able to understand the implementation as well as the approach that I have told you just now. Okay, now let's see the implementation for this question. So here the implementation, here in the implementation thing, I have this class index that I have taken it. This is the only, there is nothing only, but we have to find that the index that we will pass here, is it valid or not. Okay, for that thing I have taken, for that thing I have checked that will is it same as -1 or it will be different. So you can take it or you can directly check it. You can make also a class of directly a thing of index only, and you can avoid checking also, and you can use it as to compare there only. That also I will show you in further implementation. Here I have taken you no need of this hands, no need of this hand here. And here I have taken the DPI. As I have told you, 3-dimensional array will be required, and index type of prefix to store the prefix here, and to store the characters that we are getting from the matching algorithm, that will be stored here in the the matrix, the 101 and 26 length matrix that I have used here. After that, these two things are only the thing that I have taken the input output input here, the three inputs, the three strings input. Then I have calculated the length of the string 1 and string 2 in n and n2. Then I have calculated this prefix function. Let's look to this function plus. Here just we are calculating the prefix while we are performing some of the looping here, where you can see if the current escape, we will take the k equals to we will take a variable k, and I will also take the prefix of a previous element. Okay, and that will be stored in the k. And now I will compare the current ith index with k, and if it is not equal to, then we will allot the k-1 index element prefix of k-1 in k. Now simply again I will check that if character at I is equal to k, then I will increment the k. Okay, and at last I will allot the prefix of I equals to k. Similarly, I am performing these things here also. Okay, on eighth array that was of size 101 and 26, and here I am using this ternary operator. If x is equal to the character of I, the character present at the ith index, I will return 1, else I will return 0. Okay, this was the prefix thing. Now when we'll come back, so no need to worry to see the number of lines of code here written here, because this is nothing but we are calculating the LCS thing only. If you have seen the LCS code for dynamic programming, then you will know that we also do these things here there also. If s1 dot caret I equals to s2 dot caret j, what we are doing here, we are checking a common element, then we are applying the KMP matcher algorithm. So this is all the things that we are implementing the things, and we are checking for every condition, that if it is greater than the previous row element, and if it is less than the previous row element, then what we will do, we will just allot the values. This all thing only you will get when you know the LCS algorithm plus KMP algorithm. That's why I'm again and again focusing on these two algorithms only. That if you know that, then just this algorithm, these things that is written here, then you can do these things. Then you can easily understand these implementation. Okay, so this was the implementation. At last we will check for the index that valid that I have told you that it was, if it is -1, then we will just break the loop, and else it is not -1, then we will keep on inserting in our answer, that will your result. And this result will be, but the problem with the result will be, it will be in opposite direction. It will be not the same as, if it answer is ABC, then answer will be your BCD, and like this the answer will be these things. Okay, sorry, if the string that we have got as a result is ABC and the answer will be BCA, that is your opposite thing. So now we will calculate this rest, and we will calculate this length, and we will store this vice versa in it's opposite in this in rest sequence. It's reverse in this rest only. And now in result, I will, if the result is empty, we will print 0, else we will print the result. So this was the whole question. The whole question you can understand with only these two things that I want to tell you, I want to explain you. If you know these LCS and KMP, then just you can do this question. You can do this question. Just if you don't know, just try plus LCS, then try plus KMP, then try to solve this question. If you're not able, just look at this implementation. You will surely understand this. Okay, you will surely understand this. When LCS plus KMP is used, the time complexity will be O of n cube. So this was all about the implementation and explanation of this question. I've told you that which algorithm is getting used. I have not explained LCS plus KMP, otherwise it should be very lengthy. It will become very lengthy. And as this question, we assume that you are knowing this LCS plus KMP. That was the prerequisite for this question. So thank you for watching this video. I hope you understood the question.